Hey there, space enthusiasts! Get ready to blast off into the cosmos with us. Welcome to Spaceverse, where the universe is our playground and curiosity knows no bounds. Join us on an interstellar adventure as we dive into the depths of space, uncovering its mysteries and marvels. From the secrets of black holes to the landscapes of alien worlds, we're here to ignite your imagination and expand your cosmic horizons. With mind-blowing visuals, expert insights, and the thrill of exploration, Spaceverse is your ticket to the ultimate cosmic journey. So strap in, hit that subscribe button, and let's embark on an epic voyage together into the vast unknown of Spaceverse. Every few tens of millions of years, our solar system embarks on a journey through a particular region of our galaxy known as the Milky Way. Remarkably, during these cosmic travels, our planet experiences significant environmental upheavals, as evidenced by ancient fossils. Let's rewind the clock about 66 million years ago. Our solar system was on the verge of crossing paths with this galactic zone. Meanwhile, here on Earth, the Cretaceous period was winding down, marking a pivotal era in our planet's history. At that time, the Earth's geography bore little resemblance to what we see today. Picture a world of extremes, where everything seemed larger, stranger, and more intense. The Cretaceous period could be likened to Earth's rebellious adolescence, marked by dramatic transformations and bold choices. A notable shift was occurring in the arrangement of continents. While the supercontinent Pangaea had long split apart, its fragments continued to drift like pieces of a cosmic puzzle. During this epoch, Earth experienced some of its warmest temperatures, with tropical climates extending even to the polar regions. Consequently, lush greenery, ancient forests, and exotic flora flourished across the globe. On land, dinosaurs reigned supreme, not just the iconic Tyrannosaurus rex, but colossal sauropods stretching over 100 feet in length and weighing as much as a dozen elephants. These towering giants ruled the terrestrial realm with unmatched dominance. In the skies, pterosaurs soared, boasting wingspans that rivaled modern airplanes. These magnificent creatures were the undisputed aerial champions of their time, exuding a majestic yet formidable presence. As our solar system edged closer to the Galactic Plane, the stage was set for a series of cataclysmic events that would forever alter the course of life on Earth. But the real action was taking place beneath the waves. The oceans were overflowing with life, from massive marine reptiles like the Mosasaurus to strange creatures like ammonites and belemnites. So where were the mammals, you wonder? Well, during the Cretaceous period, mammals were tiny and unimportant, smaller even than rabbits today. Anything bigger than a meter on land was a dinosaur, unquestionably one of the most successful creatures to ever roam the Earth, ruling the planet for over 150 million years. Then came that dreaded day. An asteroid larger than Mount Everest was hurtling towards Earth at a staggering speed of 43,000 km per hour. To put that in perspective, the speed of sound is only 1,200 km per hour. As it crashed through our atmosphere, it squeezed the air in its path, heating it up so much that it could have been as scorching as the surface of the sun. When it slammed into our planet off the coast of what's now Mexico, it unleashed chaos like never before. The impact was disastrous, almost like something out of an apocalypse. The force was so immense that it sent shock waves rippling through the Earth, flattening everything in its wake, wiping out forests, and shattering mountains. A blazing heat wave followed, burning vast stretches of land to barren wastelands. Among the first casualties were the mighty dinosaurs like T-Rex and sauropods. The impact also triggered colossal tsunamis that ravaged coastlines. The intense heat vaporized rock, creating sulfuric acid that rained down into the oceans, mixing with toxic metals like lead and mercury. This deadly cocktail spelled doom for over 90% of marine phytoplankton, the tiny plants that form the base of the ocean food chain. Meanwhile, those creatures that took to the air faced a similar fate, unable to escape the acid rain. Forests burned across large areas, and around half of all plant species vanished, leading to a complete breakdown of a food chain. If an advanced civilization had visited our planet at that time, they would have been astonished to find Earth drastically altered from when they first arrived in our solar system. Yes, our planet underwent irreversible changes. The once mighty dinosaurs, who ruled for eons, were now mere fossils buried deep within the Earth's crust. But where did this catastrophic asteroid come from? Remember how we talked about our solar system passing through the Milky Way galaxy's plane every 30 to 34 million years? Scientists at the Cardiff Center for Astrobiology believe they've figured it out. As our solar system journeys through the densest part of the galaxy's plane, powerful gravitational forces from vast clouds of gas and dust knock comets off their paths. They call it the bounce effect. Some of these dislodged comets end up colliding with Earth, potentially explaining where the asteroid originated from. This challenges the previous notion that it came from the asteroid belt or the Oort cloud. The Cardiff team supported their argument with a computer model they created. It suggests that as our solar system moves through the galactic plane every 35 to 40 million years, the likelihood of colliding with an asteroid or comet increases tenfold. Furthermore, when they compared their models with real evidence from Earth's craters, they found that we tend to experience more collisions roughly every 36 million years. On another front, Dr. Michael Rampino from New York University proposed a different idea. He suggested that as our solar system passes through the galactic plane, it heats up the Earth's core. This heating could lead to massive volcanic eruptions and potentially even split continents apart. You might have heard of the Deccan Traps, one of the world's largest volcanic regions, mainly found in west-central India. Towards the end of the Cretaceous period, these traps were forming and heading towards a collision with Asia. What exactly caused the Deccan Traps to form is still up for debate. While some experts think it was due to the movement of the Indian tectonic plate over a hotspot called the Reunion hotspot, recent studies suggest it might have been because the Earth's core was heating up as we passed through the galactic plane. Meanwhile, the scientists from Cardiff have an interesting take on the bounce effect. They think it might not have been all bad news for life on Earth. They suggest that when an impact occurred, it could have thrown debris containing tiny organisms into space and across the universe. This idea aligns with a theory called panspermia, which suggests that life exists throughout the universe and can spread through comets, meteoroids, asteroids, and planetoids. According to this theory, life on Earth might have originated from these microscopic life forms that traveled through space and survived entering our atmosphere, eventually leading to the development of life as we know it. Now, here's the not-so-great news. Our current position in the galaxy suggests that we're getting pretty close to passing through the galactic plane. But don't worry too much, because not every scientist thinks that this event spells doom for us. Corinne Baylor-Jones, an astrophysicist at the Max Planck Institute for Astronomy, says it's highly unlikely and not something we should be losing sleep over. According to him, the chances of it happening are so slim that it's not usually even worth mentioning. He points out that if you change some details about how we describe the galactic plane, you might get totally different results. He also reminds us that the models we use don't consider the possibility that some craters might have been caused by asteroids closer to us than the Oort cloud. And even if the bounce effect did lead to a global disaster, we wouldn't have to deal with it for hundreds of thousands of years. Who knows where we'll be then? But if we want humanity to keep going strong, we've got to start thinking about becoming a multiplanetary species. Otherwise, we could end up facing the same fate as the dinosaurs. And that's it. Thanks for tuning in to Spaceverse. We've journeyed through the cosmos, exploring the wonders of our universe together. Don't forget to leave your thoughts in the comments below and hit that like button if you enjoyed the video. Make sure to subscribe to Spaceverse for more fascinating content about space and beyond. Until next time, keep looking up because the mysteries of the universe are waiting to be discovered. Stay curious, space explorers.